Chapter 6 only has 4 sections, and I don't know how long they are, so hopefully it's a friendly chapter. At the end of section 5, chapter 5 and section 5.8, we solved equations that had like an x squared by factoring, and usually when we have an equation, which is a problem with an equal sign, so if we have an equation and the highest exponent is a 2 for the variables, we expect 2 solutions. And in chapter 5, we solved problems like x squared plus 6x minus 7 equal to 0 using factoring. And if the problems weren't set up to solve by factoring, we rewrote the problems so that we had the left side factored and the right side 0. In section 6.1, we're going to learn another strategy for solving problems that have the highest exponent of 2 by something called the square root property. Just like in section 5.8, the problems needed to be set up specifically to solve by factoring. Similarly, the problems need to be set up in a specific way to solve using the square root property. And that way is either a number times some variable squared equals a constant, or a parenthesis squared equals a constant. So it's basically going to be a coefficient times some variable squared, the coefficient isn't squared, equals a constant, or some parentheses with a linear equation inside equals a constant. If I get something set up like this, something like 9x squared, can't even spell half the time, constant, gosh, I spelled it wrong twice, oh my gosh. This is because I'm thinking about what to write and say next. But if something like that can be solved by the square root property. There's a coefficient times a variable squared equal to a constant. A constant doesn't have a variable. Or something in the form like 5x plus 3, some sort of linear expression equal to a constant. Those are the kinds of problems that can be solved with the square root property. If a problem's not written in that form, there is a way sometimes to take problems like that and to turn them into this form, but we don't do that in our class. To solve using the square root property, it's fairly easy. I'll show you an example or two. The first example I wrote is solve 16x squared equals to 81, and that's perfectly the form. It's a coefficient times a variable squared equals a constant, and to solve with the square root property, I need to do something to force 2 solutions. And square root property, gets its name because I'm going to solve by taking the square root. And so I'm going to take the square root of the left side, and I'm going to take the square root of the right side. That's what the square root property forces on me. If I just did that, I'm not going to get 2 solutions. So next to the side that has the constant, we put that plus or minus symbol that we've seen a couple times this semester. That is the shell of what I need to do. The square root property, I just say it's square root plus or minus square root. I'm going to take the square root of both sides. On the left-hand side, I'll take the square root of 16 and the square root of x squared separately. The square root of 16 is just 4, and for the x, I divide its exponent divided by 2. The index gets divided by, the exponent gets divided by the index, so I snuck the index in there. So the left-hand side, square root of 16 is 4. The variable part, you divide the exponent by 2 and you get a 4x. The right-hand side, the square root of 89 is just 9, but I have the plus or minus signs in front of it to represent I'm going to have two solutions. After I do the square root of both sides, I still need to isolate the x. I divide it by 4, and I got x equals positive or negative 9/4, which is probably the best way to write the answer. I'd say it's the preferred answer. This shows that there's two answers, positive 9/4 and negative 9/4, and it writes them efficiently. The answer also can be written like we did a lot of answers in Chapter 5 with the two solutions separated by a comma. And anytime you have a problem that has an equal sign and you get a numerical solution, you could check. So I went back to the original problem and I checked. I said, if I plug in negative 9/4 for x, that's what you would get if you plugged in negative 9/4 for the x. Does it make a true statement? Meaning when I plug the answer that I think is right in on the left-hand side, does it make the left-hand side equal the right-hand side? When I hit equals, I get an 81, so I can check. And I did the same thing with the positive 9/4. I checked it by hand, not without using my calculator, but it is checkable by your calculator. So that's the first kind of problems. A coefficient times a variable squared equals a constant. The second kind of problem we're going to be asked to solve is a parentheses with a linear equation inside of it, something that would graph to a line, and squared equals a constant. This is a little bit harder, but I think I can deal with it. The checking is a little bit clunky by hand, but let me do the same thing. I'm going to solve using the square root property. The square root property, I take the square root of both sides, and because I know I need to get two solutions, I put a plus or minus square root on the side that has the constant. I did a prime factor tree to reduce the 48 under the square root, so I did 48 equals shift quotes. I'm not in the right mode. I go to mode 1 and do 48 equals shift quotes and get 2 to the 4th times 3. So when I reduce the square root of 48, I did the prime factor tree, and I decided in the square root of 48, I'm going to get 2 2's in front of my radical and a 3 under my radical. So as I went to do my algebra, I worked on the right-hand side, which was harder for me, and I rewrote the right-hand side as 4 square root of 3. On the left-hand side, square rooting cancels out squares. And so it's just going to leave me with the x minus 8. And since I've gotten rid of the square, I don't need a parentheses on the left-hand side. And then I just add 8 and add 8. And there are two solutions implied by my algebra. The two solutions are x equals 8 plus 4 square root of 3 and x equals 8 minus 4 square root of 3. And you'll see that 8 plus 4 square root of 3, it doesn't equal 12 square root of 3. Those aren't like terms. You can't combine those and get a 12 square root of 3 comma 4 square root of 3. Those are the answers. Because the answers look essentially the same except one has a positive sign, the other has a minus sign, writing the answer with the plus or minus symbol is preferred. Just like in the last problem, writing the answer with the plus or minus symbol was preferred because the answers look identical except one has a plus sign, the other has a minus sign, or one's positive, the other's negative. If I wanted to check, I wouldn't check by hand. The original problem is 8 x minus 8 quantity squared equals 48. I would take whatever answer I want to check, plug it in for x, and I just break out my calculator to make sure that it actually checks. So let me just do my checking. 8 plus 4 square root of 3 minus 8 quantity squared. That's what I'd get if I plugged in the first solution. And because when I plug it in, it matches the right-hand side, I know that answer is right. Similarly, if I wanted to change the x to the second solution, 8 minus 4 square root of 3 minus 8 squared equals 48. So I'm just trying, not with a lot of success, trying to change this x to 8 minus 4 square root of 3, leaving the minus 8, leaving the 48. And then that on my calculator wouldn't be that. Gosh darn. It would be that. And then when I check it, I get 48 equals 48 again. So they both check. About ready to get into the section and do some problems. In the world of this section, most of my answers I'm going to have a plus or minus sign, but there's going to be a time where I don't write a plus or minus sign in my answer. And I'll try to talk about that as I go through. I've written up here when I think my best answer should have a plus or minus sign. The first problem that I did, the problem that was a number times x squared equals to a constant, the first problem I did, those problems without parentheses always have plus or minus signs in our answer. The parentheses problems have plus or minus signs in my answer if on the right-hand side there's a square root left or an I, or both a square root and an I. So the two times where I get plus or minuses in my answer, the no parentheses problems, like I did for my first example, the parentheses problems where the right side simplifies and it still has a square root or an I left, which was like the example I did. Sometimes we're going to solve the parentheses problems and the right-hand side is going to have no I and it's going to have no square root. And when that happens, my best answer is going to be two separate numbers without a plus or minus sign. I'll try to, as I'm going through the problems, explain. So problem 2 doesn't have a parentheses. My best answer is going to have a plus or minus sign. If I was going to solve problem 2, I would just go square root of the left side equals plus or minus square root of the right-hand side. And I'm not going to get fancy with reducing. I'm going to get slick. Square roots cancel out squares. So my left-hand side in number 2 is going to be y. And I don't even need my calculator for the square root of 25. That's one that I have memorized. And that's it. I'm done other than I could check. Best answer has a plus or minus sign when there isn't a parentheses. Similarly, number 4, it doesn't have a parentheses. My best answer is going to have a plus or minus sign. I'm going to solve by square rooting the left side, plus or minus square rooting the right side. On the left side, I'm going to square root the 25 separately from the square root of z squared and then multiply the results. The square root of 25 is 5. Again, that's one that I just have memorized. And for the square root of z squared, the square root symbol cancels out the square and it just leaves me with a z. On the right-hand side, I know the square root of 81 is 9. I don't need a special calculator for that. That's one I have memorized, but you can use your calculator just fine. I'm going to divide by 5, And then usually I write the plus or minus sign before a fraction if there's a fraction answer. That would be my answer for number 4. They both would check. For instance, if I wanted to check the hard one, z equal to negative 9/5, I'd go to the original problem and say, is 25 times negative 9/5 squared equal to 81? And I just mindlessly press buttons. 25, parentheses, fraction, negative 9/5, parentheses squared. Oh, I don't even know how I did that. Parentheses squared. And it would check. Both the numbers will check, and I'm just saving some time by not checking. But I should. I do have my answer sheets handy, so I should be checking those now that I think about it. Six, I'm going to go square root of a squared equals plus or minus the square root of negative 16. On the left-hand side, square rooting cancels out squares. It's just going to leave me with an a. On the right-hand side, the square root of a negative turns positive if you bring an I after the square root. Forgot the plus or minus sign, minus 2. Need to get 2 answers. If I don't have the plus or minus sign, I'm only writing 1 answer. And then the square root of 16 is just 4. So 6, my answer would be plus or minus 4i. If I wanted to check on my calculator, I'd have to go back to mode 2. And if in mode 2 I entered like 4i squared, I'll show you how to do that just in case you're interested. So if I wanted to check the 4i to make sure it's right, I change that a to 4i, and let me do mode 2, and then parentheses 4. In mode 2, the ENG button is the I, so ENG parentheses squared, that's plugging in 4i for the a. Then when I hit equals, I see that it checks. I could check the negative 4i as well, see if the quantity negative 4i squared equals negative 16, just doing parentheses negative 4. In mode 2, the ENG button's the I, and it works as well. My answer should have that plus or minus. All of the problems in this section that don't have parentheses, I'm going to leave a plus or minus in my answer. In problem 8, I'm going to square root plus or minus square root. On the left-hand side, I'm going to do the square root separately. You don't need to write as much as I'm writing. If you can do the square roots without doing the separate writing that I'm doing, better. It's better than not. On the right-hand side, if I'm doing the square root by hand, I'll make the negative under the square root and I after the square root. On the left-hand side, the square root of 9 is 3, the square root of a squared is a. On the right-hand side, the square root of 16 is 4. Divide by 3 and I get a equals plus or minus 4i over 3. I would more likely have that 4/3 written to the left of the fraction. It just kind of wound up close to the numerator. It's okay, but it's preferred to the left of the fraction. $10, I'm going to need to be in mode 1 because I'm going to need to reduce a radical. In 10, I'm going to go to the square root of d squared is plus or minus the square root of 24. On the left-hand side, the square root of d squared is d. And on the right-hand side, I'm going to do a prime factor tree for 24. I'm going to go mode and then 1. Type the number 24. Type the equal sign. And then the shift key. And then this degree, minute, second quotes key. And it says 24 is 2 times 2 times 2 times 8. And when I go to reduce the square root of 24, because it's a square root, every time I get a pair, I get one of those out front, and anything that's not a pair gets shoved back under and multiplied. So for 10, I'd probably say my answer is plus or minus 2 square root of 6. Twelve is similar. I do the square root of x squared equals plus or minus the square root of negative 54. Square root of x squared is just x. On the right hand side, I need to make the negative 54 under the radical positive by creating an I after the radical. Do a prime factor tree for 54. 54 equals 2 times 3 times 3 times 3. So the square root of 54 gets a 3 in front of the radical after the plus or minus sign. And under the radical, you get the 2 and the 3 that aren't paired up. So for 12, I think x equals plus or minus 3 square root of 6i feels good. When I get to parentheses problems, let me put these in a part 2, just so all the parentheses problems are kind of stacked up together.